Professor Xavier Reshapes from THALES. I'm very pleased to be here for the fifth time, I think, for this event. And today my main purpose will be to present not necessarily what has been done, but more something related to the future and the impact of digital economy and on the disruption on air traffic management, among others. So today the aviation industry is under pressure, and for different reasons. The growing demand, impact on the air service provider, airlines and IT distribution, infrastructure provider as well, like air navigation services, airports, and ground handler, and obviously as well the aircraft providers. All the aviation industry is impacted by, let's say, new technology trends and a real technology disruption, which is a digital transformation. So how to manage and handle big data and analytics. There is more and more data collected in the aviation world. How to introduce artificial intelligence to support our customer. How sometimes as well to implement a safety cloud platform, so not necessarily the physical equipment, but to introduce all these elements within the cloud. And not the least, which is how to manage and the security of those data and the exchange via the cyber security implementation and protection. And clearly in the aviation as well, you can face more and more connectivity and Internet of Things, I will say more on the passenger journey. If we take the example of data collected by an air traffic management system, in the past, ANSPs invest billions annually to collect and deliver critical information for the air traffic control and to ensure the safety of the flight. But 10 seconds later, most of that data collected are thrown and drained and never to be used again. So that's one of the aspects which need to be changed today. So what we want to help our customer, wherever they are, to master their decisive moment all along the critical decision chain. So for that, we are mastering all the step of this critical decision chain, from the sensor and the collection of data, for instance, navets, radar, and more classical technology. Then how to transmit and store those data, to use those data for the future, and how to use those data to extract and to benefit for the final decision. So in that respect, we are harnessing key technologies in our verticals segment. I mentioned before the 5 segments to address connectivity and mobility, cybersecurity, big data analytics, and artificial intelligence. For that purpose, the last 3 years, at the group level, we have a huge investment in acquisition of different entities which were all involved in this digital transformation technology aspect. The last one, not the least, is Gemalto, the one who produces all the SIM card you have in your cell phone, but all the security SIM card you can find in a different equipment in an airport or aircraft even. Evolution, how the aviation environment will deal and when, that's the key question. And when the air traffic management will be disrupted by this artificial intelligence aspect. You can see from the bottom the point of view of aircraft manufacturer, how the artificial intelligence will in the future, in the near future maybe, 2050, so it's really tomorrow, I will say, enable a single pilot operation. That's one of the perspectives and the objective on the aircraft manufacturer. On the other hand, there is, in parallel, a revolution in the mode of transportation. So we are seeing already on a day-to-day life everything related to autopilot for the car, so movement, transport of people without any pilot behind the wheel, and autonomous urban operation. It's something which is already under experimentation. It's not spread all over, for sure, but it will happen even shortly than the pilots. Another hand, there is all the aspects linked to the drones development and delivery, and that's where I will say the classical air traffic management environment will be definitely modified, how to manage, let's say, pilot aircraft and unmanned aircraft. Do they have to be segregated in different airspace? For the time being, it will be the case, and it's most of the regulation. But tomorrow, the objective, and we are working on that, is to see how to integrate all those different and maintaining the safety of all the airspace. On the artificial intelligence, we have developed a lot of expertise in different places, and we have different labs spread all over the world in order to collect all the good feedback, let's say, of those either laboratory, research institute, or even startup who are working on artificial intelligence and how to use their output for new idea and new process. If we look at an automation system, how artificial intelligence can improve and augment the automation capability. And we have focused on different topics, I will say. One of the most important is linked to the safety and the conflict resolution. For an air traffic controller, it's a common, let's say, tool. But we are working on that. Our artificial intelligence can improve and facilitate the air traffic controller decision. User experience, we collect information from the air traffic controller behavior as well. Intelligent capability and how to monitor controller performance, mainly for the time being in a training facility when we have some device which can record, let's say, eyes tracking, so where the controller is looking at the screen in order to collect and to improve the performance of the air traffic controller. And the main idea is to collect those data and then to process those data with artificial intelligence. But one of the key elements is we have to keep in mind is it has to be trusted and it has to be, I will say, genuine in the sense that the man will still remain at the final decision step. So that's another example of how to improve controller efficiency, to develop tools for best user experience and application and services for added value, but to maintain, which is paramount for us and for all the stakeholders, is the safety in the air and mainly for the passengers. Another aspect, which is what we call an ecosystem, is really to grab all the elements and all the aspects, all the stakeholders. It's to address the flow management, so air traffic flow management. So it's not a tactical equipment or functionality, but it's more strategic in order to improve flight efficiency and flight accuracy in their and punctuality in the journey of all the passenger experience. Taking into consideration the complexity of prediction and how to manage different airflow, how to dynamically manage the airspace environment, and as well taking into account as well weather information, which will be along the journey of the aircraft between one airport and the next one. So it's a quite interesting development mainly to improve at the regional level the flow of aircraft and to avoid bottlenecked. And I will say another element I have mentioned before was the drone and the fast-moving market. So some prediction will say that as on the blue line, it's let's say the increase, progressive increase of the fleet of classical aircraft fleet, and you can see on the red dot or the red line how the prediction of increase of drones will be in the air. It's definitely, let's say, a new technology, a new service, a new business model, and a new activity we have to take into account in our global environment as all involved in an airspace ecosystem. So we are developing more and more, and we are proposing on the market some, at the first levels, the equivalent of an air traffic management system for controller, but much more automatized for what we call UAV traffic management. So it's the transposition somehow of the rules and some aspect of the air traffic management for classical aircraft, but giving some automative mechanism to speed up, let's say, the process of allowing the airspace access to the UAV or the drones, civil drones, I prefer to clarify. Airspace management, so how to manage the airspace between piloted aircraft and unmanned aircraft, and the last but not the least, airspace monitoring as well, to be sure that there is a conformance between what was planned for the drones and what is effectively and operationally implemented. So that's just a global vision of all the different steps and how to combine in the future what is for the time being considered for most of the regulation in the country as uncontrolled airspace where UTM can fly, UAS can fly, but the projection in the future is really to have a UAS integration into controlled airspace, and we have to consider this as an objective. And clearly, for sure, one of the examples we used to have for this new technology aspect and how to manage this new flying object, I will say. For sure, there will be regulation, but we have to consider that regulation needs to be adapted to the context. So when you have, like in the road, I will say, for 2D vehicle, when you have a low density and a low risk operation, you have a limited regulation and a limited enforcement. And clearly, when the high density and high risk and the risk increase because of the density and the urban environment and things like that, that's where you need to implement much more stringent regulation, but without limiting somehow the access to the airspace. And so the last topics I would like to address regarding this digital transformation is not unfortunately a new function, but it's a mandatory aspect which needs to be addressed. I will say a little bit like safety 20 or 30 years ago, when you have to consider cybersecurity as a parameter within the overall environment of airborne environment, and everybody is exposed. So thanks today, there is not so many events which were drastically leading to a catastrophe or things like that, but we consider that it's no longer an option for the air traffic management environment. And as I said before, there is more and more connectivity, there is more and more exchange of data between different stakeholders. There is not necessarily isolated and in silo, and so the progress will increase this exposure to all the systems which are deployed on the ground or even in the air to cyber security or cyber threat. And so that's one of the aspects which need definitely to be tackled and addressed at a high level, at the management level even. As I said before, no severe disruption in air transport, but for sure the best way is not to wait for the disruption, is to be prepared for that. The cyber threat is increasing and the surface, as I mentioned, are growing, surface of attack. All the stakeholders in the aviation domain are exposed to that. Airport, for sure, surveillance, air navigation services, aircraft and data parts supplier, MRO, I will say, operational control center for the airport, and even the maintenance control. So because all those are relying on the IT system, and they are more and more exposed. So you need to really address globally this new threat. That's a few figures when you can see how we have built our, let's say, credential and expertise on the domain. We have more than at the group level, and we are using all the group resources to address the different segments of activity we are addressing for customers. But we have more than 2,000 cybersecurity specialists working for the different domains, and among others, aerospace domain. Our vision and our response to the cyber threat is really to address cybersecurity for all the critical infrastructure and operator. And in the case of our air traffic management activity, we customize somehow and we apply the main rules to all the air traffic management mission and architecture. And we can consider that in 4 different steps. The first step is to protect what is existing, so to have an assessment of what is existing and how to protect it. But protect is, we will never be protect 100%, so you will need to be able to detect if there is an attack or something. And if you detect such event, the key element is how to respond, in a sense that how to isolate, let's say, the attack in order to minimize the impact on the overall infrastructure system. And last but not the least as well is how to increase the resilience. So it means it's not only a matter of technology, it's a matter of training. We used to say that there is 3 pillars in the cybersecurity domain: training, process, and technology. Technology helps to protect, process helps to react and to recover, let's say, after an attack, and training is to reduce the number of unfortunate and involuntary penetration of bugs or different malware, which are most of the time still, for the time being, considered that more than 50% of cyber events are provoked by internal action and not from the external world. So what we can do as industrial partner, as I mentioned before, leverage our experience in the various domains for the benefit of air traffic management or aerospace environment, provide in-depth cybersecurity from boundary protection to core components. That's more a technological aspect. Develop the business solution through deep aviation domain knowledge. So it means that, as I said, it's not concerning only one element of the different stakeholders, but all the elements. So it's more or less, I will say, a collaborative decision mechanism between airlines, airport, ANSPs, and so on. How to propose preventive cybersecurity maintenance in existing system and the risk assessment for existing infrastructure. Feed cybersecurity monitoring, so in the aviation domain, with a lot of other cross-border domain when you can collect a lot of information via cybersecurity operation center. and support the customer with our dual expertise in cybersecurity and in aviation to be sure that we address properly the needs of, on the ground. And last but not the least, we said that digital transformation will happen. It's already happening. It cannot be done without trust, but for sure there will be no trust if there is no cybersecurity, due to the fact that all the elements are exchanging a lot of data between themselves. Thank you.